Now, when I was finishing up the video series for the section on alkenes, I couldn't remember if I had made a video discussing cis-trans explicitly. I know I've done videos about EZ, but I don't know if I've done them about cis-trans, and I looked through, being honest with you, I didn't feel like watching to see if they went through the detail I wanted to. So here's a special video, hopefully not repetitive video, on cis-trans. Now, a couple of big comments about cis-trans. It is not the more versatile naming system. When we were using cis-trans, what we were trying to do is describe orientations along a double bond, specifically how the groups attached to the double bond are oriented relative to each other. Now, it is less versatile because it requires two of the groups to be the same and on opposite sides of the double bond. So if we were to have two methyl groups on one side and this being an alkyl group, so basically we swap these two groups together, we couldn't use the cis-trans for this, because the cis-trans refers specifically to the two groups that are the same. So if we look at this one, we're going to focus explicitly on the orientations of the methyl groups because they're the same groups on opposite sides of the bonds. Now, to name the compound, like always, you're typically going to take the longest carbon chain. This generally gets around you having conflicts where, okay, is it cis-trans relative to this one group? Let's say you have, in this case, two alpha groups off of it. The parent chain is probably going to absorb the carbons that are the longest if there are two groups that are the same. But I'm digressing. We're going to focus on the methyl groups here. Now, when they are cis to each other, it means they are on the same side. And the way I remember is it's going to form the letter C upside down when they are cis to each other. They are trans, like transatlantic, when they are across from each other. So in this case, our parent compound, 1, 2, 3, 4, 5, 6, 7, is 3-heptene. We have 3,4-dimethyl. And what we have to designate in front of this whole compound is that they are cis-trans. But you can see from this naming, we've associated all this. So these are different isomers of 3,4-dimethyl 3-heptene. In this case, this would be trans. And the one down here is the cis. So, what was the point of this video? Cis-trans is limited. Two groups have to be on opposite sides of the double bond and they have to be the same group. So in this case, we have two methyls. So when we say the cis-trans and we draw out the compound, we're going to look for the two groups that are the same. Again, we shouldn't have issues of having to choose which the two groups are referring to. Typically, the longer parent carbon chain is going to absorb most of it. So really, we have two unique groups on there. We're going to name them the same way, but we're going to name them trans if the similar groups are opposite each other in the double bond, and cis if they're on the same side of the double bond.